Hello and welcome to the new season of the Computomics podcast. Our guest today is Deputy Director of the Australian Research Council's Centre of Excellence for Plant Success and Chair of Prediction-Based Crop Improvement at the University of Queensland, Australia. Mark Cooper, welcome.
Thank you very much, Anna. Pleased to join you.
We are pleased to have you. And as you've been warned, and as our audience knows from previous episodes, we love to start with a little icebreaker. And I was wondering, you are a Scot living in Australia. What is your most Scottish habit?
Most Scottish habit is probably avoiding being Scottish, probably. My parents migrated to Australia when I was 15 years old, and I find myself in a situation where in Australia, people don't believe I'm Australian. In Scotland, they don't believe I'm Scottish either. So my accent is this strange hybrid, and I find that I manipulate the way I speak with the audience that's listening when I can hear them. So a bit of a chameleon trying to avoid my Scottish accent.
I love that, though. And I guess having your language be a hybrid also in a poetic way almost reflects a little bit of your work as well. Maybe we can actually, before we jump into that, for our audience, I was hit by Murphy's Law today. So what you might hear in the background is a road crew that decided to open up their construction right next to our studio today. So there's no way we can avoid that sound wise. So pardon everyone for that little bit of background noise. But that being said, we'll have an exciting conversation about, among other things, your 20 years in the industry. You worked at DuPont Pioneer. And I was wondering, Mark, what insights can you share with us regarding breeding strategies and breeding programs in large seed companies like DuPont Pioneer?
Yeah, I think that one of the reasons I joined the commercial breeding sector was just to learn how breeding programs operated at very large scale, and when the breeding programs had been operating over a long time frame. So the company that started breeding, Pioneer, started in the 1920s. So you had this long-term historical breeding effort that you could build on over cycles. So there were generations of plant breeders. So I think that was certainly something that really inspired me to learn more about that versus a public sector breeder where you might not have that same scale and history of breeding. So I learned a lot from immersing myself in that culture.
Mm-hmm. I wonder, though, I mean, it would be a classic way, I guess, you have more scale, but in a way you might be more restricted because it is commercial, because you also have to worry about scale. How much freedom did you or your team have to set, for example, R&D goals or to experiment?
I was really fortunate in joining the company, Pioneer, that eventually became DuPont Pioneer, through a collaboration in the first place, where the collaboration was set up while I was in a university position, and it was intended to explore new frontiers in predictive breeding. And that became the foundation of the job that they asked me to take with the company. And really, they were looking at opening up new frontiers. So in my case, I went into an organization with quite a bit of freedom to actually explore new technologies and actually establish new global collaborations with other universities and other organizations around the world. So the one thing that I learned very quickly was that collaboration is definitely a possibility in the commercial sector. And there are probably a few different rules and reasons for doing it than if you were a university academic researcher.
Right. What would you say, what are those, if you can share, what are those rules or those main, I guess, variables that are relevant for a collab in that space?
So there has to be a definite purpose for doing the research towards the application in breeding, and you're generating internal knowledge that you want to use to develop new products that are ultimately going to be used by the industry that you're actually serving. And clearly in the commercial world, you want to do that ahead of your competitors. So you have to be careful about how you develop and share information that clearly belongs to the organization. And the reasons for talking about it externally usually come to explain the reasons that you were successful and to help advance the global scientific community. So we had a very purposeful external communication strategy that was to help advance the training of the next generation of scientists that were going to be important for the long-term success of the commercial company.
Mm-hmm. You also referred to kind of moving the frontier, the technical or technological frontier. Can you maybe give an example where you did that and what you learned from that?
Yep. Well, one of the areas where we had to advance a lot of our capabilities was in the development of new models for prediction using genomics information with advanced ability to measure traits on individuals in many environments, so phenotyping of different traits, and building models that connect the genomic sequence information with those phenotypes to build the predictive models. Those were computationally very intensive. So as well as generating a lot of the data, we had to build new software and new hardware, computer hardware platforms that allowed us to scale and compute the solutions to the models in a very quick time. So while you might think of doing an analysis that might take a week, in a scientific project in a university, if you have to make decisions overnight in a breeding organization to act on those decisions, you obviously have to develop computational infrastructure that allows you to put a lot of your research findings into practice very quickly. So we had to advance a lot of the computer hardware and software technologies, as well as doing the research on the biology we were interested in.
That makes total sense. So this would be something that I think you worked on drought adaptation in maize.
Yes.
Was that an area where this also came into play, I'm assuming?
Definitely. So we were using a lot of data collected from experiments that were running globally. We had to transfer those data back to the central computing capabilities. You can only do so much remotely. Those were analyzed. The results of those analyses were made available to a global community of researchers that were then using the results of those analyses to make decisions that impacted different stages of breeding programs, right through to the commercial release of new hybrids and the support of those hybrids for use by farmers.
So it seems like you really enjoyed your time, and you said before you learned a lot. So how come you went from the commercial space, from industry to university? You're at Queensland University right now.
Yep. So when I was in the commercial sector, I would have been very happy to continue on as a maize breeder. I had a lot of collaborators and colleagues globally, and a number of them were always interested in thinking about how you train the next generation of researchers. And a number of the colleagues asked me if I would have an interest in coming back to the university environment to help advance some of the thinking about training of plant breeders for the future that are going to rely on these prediction methods. And that became the position at the University of Queensland that was created as an opportunity for me to come back and participate in that training. And that was an exciting possibility. I guess you go through phases in your research career. I'd say that my first 20 years were a very ambitious learning activity. I then had a very successful 20 years of actively putting into practice a lot of the methods that I learned how to develop and apply in breeding. And what I'm doing now is very exciting, and that is working with a lot of colleagues on thinking about how the next generation should be positioned to do what I'm doing now, but to do a lot better than I'm able to do it right now.
And how should they be positioned? Maybe you can delve or take us with you into your core elements of teaching or of creating that new gen.
Yep. No, I think that one of the things that was really interesting for me in looking at my career development, when I started as a researcher, I was very interested in quantitative modeling methods. Computers were things that were not directly in front of you. They were in rooms elsewhere. You might have had a keyboard, so you were working with these large computers in rooms a long way away.
Mm-hmm.
And they were generally specialized and hard to use. And so it was a much slower process where you spend a lot of your time getting data, organizing things before you use those computers. Whereas today, computational tools are much more available to people. People are much more skillful in using these technologies. So I think learning how to use those tools very quickly is a skill that the next generation of breeders will have. That is something that will change the way in which they should think about the interface between biology and mathematics and modeling and prediction.
But would you say there is still a gap between, I guess, the training of agricultural scientists and the needs of the industry, or how do you make sure that, because it seems to be a little bit of a race always, right? How do you match the needs of the industry and the opportunities there with what scientists, I guess, learn and train for at university or in their early stage research?
Yep. No, I think that gap will always persist. There's always going to be new technologies that will create the gap. I think that the best way I would consider that is to understand some of the key features that are the gap between the way industry is currently operating or potentially could operate if everything was going very well, and identify the areas that the new researchers should focus on building skills in, so that they, as best they can, close that gap and get closer to the cutting edge of the technologies. They'll eventually get there. It's a question of how quickly they get there. And if the research is done in a very constructive way, particularly between public and private partnerships, I think it creates an environment where you can close that gap. The researchers can get closer to the cutting edge more quickly.
Yeah, it seems collabs, or like you were saying just now, partnerships are also very important and play a key role in this stage at university, as it did with DuPont Pioneer before. So speaking of collabs, you have an ongoing collab with Computomics. What is the purpose of that collab? What do you do?
So part of the collaboration is to come together on our common interests, and how do you use a lot of the new data sources in genomics and measuring traits and all the intermediate technologies that can be applied to study the translation of sequence information into the characteristics of organisms, plants, for plant breeding, and to apply the new mathematical technologies that are becoming available to study these large data sets, particularly as people might be familiar with the ideas around artificial intelligence and machine learning. I think these bring new tools, and Computomics has a very strong team and a very direct interest in these technologies, as we do at the Center of Excellence for Plant Success. And there are opportunities to work together on specific projects to compare our experiences and work out if there are combinations of the methods that we're each working on that we can both learn from. So the collaboration is set up around studying particular data sets in common and comparing our methods. And in fact, today I was actually in a collaborative meeting with Computomics, across continents, discussing exactly those types of activities.
That's exciting. Are you in the process of setting it up, or can you share a little more details of basically how the workload is distributed between your university unit, your research team, and
Yep.
Computomics on the other side?
We have methods that we're both working on, and we're in the process of conducting experiments. So we're generating empirical data. We also have the ability to take our prior understanding of how the biology we expect to work in these experiments, and we've been building computer simulation models that represent how we expect that prior knowledge to play out inside these experiments, and these become hypotheses. So what we've done is, ahead of having the experimental data available to us, we've been running the simulation models and using the results of those simulation experiments to apply our different analysis models to test what we would expect to happen in those experiments. So we've now got working hypotheses of predictions from our models applied to the simulation data, and we'll be testing those in the experimental results as they become available.
So in a way, you're also testing how well the predictive models work, right?
Correct. Yeah. Yep.
And where do you see the application once? I'm assuming this runs for a little while. What's the timeline, and what's the end goal of the cooperation?
So the end goal is, instead of having to wait 10 years to determine whether or not a particular prediction method could allow you to identify suitable genetic combinations you could create in a breeding program, we could run the models, make predictions, and get there in half the time or less. So we could actually make more rapid decisions about the paths we want to take inside breeding programs using the predictive models, rather than going through a slower series of cycles of the breeding programs than we currently have to. So we're going to test that in a number of plant species, from model systems through to field crops.
Mm-hmm. Which plant species are you targeting at the moment?
So at the moment, the model systems that we're looking at are the classical model workhorse, Arabidopsis thaliana. So we can actually turn over cycles and phenotype individuals and test out our models in that. We have very detailed understanding of the sequence and some of the biology that we're trying to manipulate. And then we will apply that to crops in the field, such as grain sorghum, which is a very important cereal for the Australian farming systems here, particularly in the northeastern part of the country, where I'm located.
Mm-hmm. It's exciting to work on something where there's such a clear, goal of application. And as we said in the beginning, obviously time is a huge factor in the commercial space as well. So I'm sure it'll be interesting for on all levels. Are there any specific technologies or prediction methods that you apply in your research with AI? Any specific ones that you can name or go into detail?
Yep. And actually, we have been running a number of collaborative symposia over the last 2 years, and we'll be running another one in collaboration with our colleagues at Wageningen University in the Netherlands later this year. And we'll be looking at hybrids of the classical prediction selection models that we're using now, using statistical methods to associate sequence variation with traits in a technology that's often referred to as genomic prediction and genomic selection in breeding. And we'll also be comparing the results of different machine learning and artificial intelligence methods for associating the sequence polymorphisms with the phenotypes and looking at hybrids of those models. Another technology that we're investigating is different ways in which we can take an understanding of how plants react to environmental conditions so that we can predict the outcomes using what we would call a symbolic crop model or a plant model. And we would combine that with the statistical and the machine learning methods in a hybrid model to make predictions of outcomes. And what we would like to be able to do is, from a breeding program, is predict how genotypes that have yet to be created would perform in environments they've yet to be tested. And so these models give us the capacity to make the predictions. The experiments are then conducted to work out, are the models reliable enough in terms of the predictions that we would be willing to make breeding program decisions based on those predictions.
Mm-hmm. Very exciting. You mentioned symposia. I believe the next one is going to be in October. Mark, how can people access the symposium, maybe as participants, and hear what's going on?
That's correct. The symposium is going to be at the end of October. There'll be a live on-site meeting at Wageningen University. But for anybody that wants to join, they can do that online, and they can register following the link that's available for the symposium on our Center of Excellence website. So you can go to the Center of Excellence's website, check for the G by E by M symposium, and there'll be a registration link there.
Mm-hmm. We'll make sure to add that to the show notes as well, so our audience can use that as well to pop on over. And is there a plan to summarize the results in an accessible manner, or will it be the classical, obviously, various research publications? You got to follow those.
So what we've done in the last two symposia, and we're planning to do that this time as well, is anybody that registers for the symposium, for any of the contributors, the presenters that give us their permission, their talks will be recorded, and people can then go back and actually go through the presentations from the speakers that are contributing to the symposium. And obviously a number of these speakers are already very active researchers and have multiple publications in this space, and all of the participants would be willing to follow up with those individuals as colleagues.
Of course, it's just always nice, and I think more events are doing this, that they make the actual talks in some way or other accessible after the fact if people can't join. But yes, we will definitely add that to the show notes. And given that our time is running a bit short, unfortunately, Mark, I just have, I guess, a bit more of an outlook question beyond the symposium. What development and technologies do you see in the future of plant breeding from where you're standing right now?
So I think that where plant breeding is going is towards a much more scalable research undertaking. So when I started as a plant breeder, every data point that you worked with largely came from things that you directly measured. And so that sets a particular scale. But today, with predictive methods, the breeding program really is becoming data input type of source for the predictive models. And the size of the breeding programs is now going to be 2 to 3 orders of magnitude larger than the programs we were running previously. So I think we're going from a very empirical activity to something that's much more scaled as a prediction method, where people are interacting with big data and the outcomes of predictions and testing a lot of their ideas in their breeding program. Rather than generating data to test models, we're going to be using our data to interact and build the models in a very iterative process over time. So we're trying to use the breeding program to, as prior knowledge, to enhance the predictive capability, and every cycle of the breeding program just allows you to improve the quality of the information that the models of the breeding program are taking advantage of. One thing I was thinking as a technology leap thing, I remember I had to give a talk once about how quickly technology shifted. And I was trying to get people to appreciate that, it's really your imagination sets the rate at which things could change. So when I was mapping out a technology such as air travel, the thing that really struck me was that one of the Wright brothers from the first powered air flight was alive at the same time as Neil Armstrong, who was the person that first stepped on the moon. So in 2 overlapping lifetimes, we went from we couldn't undertake powered flight to someone landing on the moon. So that sort of just gives you an idea of how quickly technologies can change. And I think that's sort of the situation that we're actually in with how we're using a lot of these technologies to help agriculture, which is obviously really important to get right globally. So, yeah.
That's actually a really cool metaphor. So in a way, you're saying we're looking at the next step is kind of the moon landing, I guess, for plant breeding, right?
Exactly. So we're sort of getting into the powered flight at the moment, but you think ahead to the moon landing. I think that's where we're headed for with the next generation of scientists that we're trying to train.
Well, we're certainly excited to be traveling to the moon with you and with many others in the field. Thank you so much, Mark, for your time.
Pleasure, Anna. Thank you very much.
Thank you for listening in today. Want to learn more? Then check out our show notes and more info on Computomics.com. If you have questions or want to propose a next guest, please reach out to us at podcast@Computomics.com.